Good afternoon, everyone. My name is Denmark Piatasa. My topic is forecasting travel demand. So, what is travel demand? Travel demand is expressed as the number of the persons or vehicles per unit time that can be expected to travel on a given segment of a transportation system under a set of given land use, socio-economic, and environmental conditions. Forecasts of travel demand are used to establish the vehicular volume of future or modified transportation system alternatives. So, demand forecasting approaches. There are two basic demand forecasting situations in transportation planning. The first involves travel demand studies for urban areas. And the second is deals with intercity travel demand. So the first is urban travel demand forecast. When first developed in the 1950s and 1960s, requires the extensive database and prepared using home interview or roadside interview. The information gathered provide useful insight concerning the characteristics of the trip maker, such as age, sex, income, auto ownership, and so forth. So there are three factors influencing travel demand. The first is the location and intensity of land use. Second is socio-economic characteristic of people living in the area. And the last is the extent, cost, and quality of available transportation services. These factors are incorporated in the most travel forecasting procedures. So, the demand forecasting approaches is land use. Land use is characteristics are a primary determinant of travel demand. The amount of traffic generated by a parcel of land depends on how the land is used. For example, shopping centers, residential complexes, and office buildings produce different traffic generation patterns. The second demand forecasting is socio-economic characteristics of the people living within the city also influence the demand of transportation. Lifestyles and values affect how people decide to use their resources for transportation. For example, a residential area consisting primarily of high-income works and will generate more tips by automobile per person than a residential area populated primarily by retirees. Sequential steps for travel forecasting. The set of zones can be aggregated into larger units, called districts, for certain analytic techniques or analysis that work at such levels. Land use estimates are also developed. Travel forecasting is solely within the demand of the transportation planner and is the integral part of the site development of traffic engineering studies as well as area-wide transportation planning. So the this is the travel forecasting process. First is land use and travel characteristics, trip generation, trip distribution, mode choice, assign trips to network, and the transit and highway system. The we tackle trip generation. So trip generation is the process of determining the number of trips that will begin or end its traffic analyzed zone within the study area. Since the trips are determined without regards to destination, they are referred to as trip ends. Each trip has two ends, and these are described in terms of trip purpose or whether the trips are either produced by a traffic zone or attracted to a traffic zone. For example, a home-to-work trip would be considered to have a trip and produce in the home zone and attracted to the work zone. So there are two trip generation analysis. First is to develop a relation between trip and production or attraction and land use. And the second is use the relationship to estimate the number of trips generation that someone. So this is the average zone income. So the next topic is cross classification. We talk about cross classification is a technique developed by the Federal Highway Administration or FHWA to determine the number of trips that begin or end at the home. Home-based trip generation is a useful value because it can represent a significant proportion of all trips. The first step is to develop a relationship between socio-economic measures and trip production. The two variables most commonly used are average income and auto ownership. Rates based on active units. The preceding section illustrated how trip generation is determined for residential zones where the basic unit is the household. Trips generated at household and end are referred to as productions, and they are attracted to zones for purposes such as work, shopping, visiting friends, and medical trips. Those an activity unit can be described by measures such as square feet or floor space or number of employees. So this is the single family detached housing. So this is the trip generation for dwelling unit, and this is the data plot of equation. So we proceed balancing trip production and attractions. A likely result of a trip generation process that the number of trip productions may not be equal to the number of trips attractions. Trip products which are based on census data are considered to be more accurate than trip attractions. Accordingly, trip attractions are usually modified so that they are equal to trip productions. So this is the table of the balancing of non-home based trips. So unbalanced or in its B trips, and the other is balanced in its B trips. Zone 1 to 3, the total. In its B productions, in its B attractions, in its B productions, in its B productions. So for example, in table 12.8b, since there are 180 in each B attractions for June 1 after balancing productions and attractions, the number of NHB productions for June 1 is also changed from 100 to 180. As you can see in the table 12.8. So the rationale behind this extra step is that true origin of non-home based trip is not provided by survey or census data, and thus the best estimate of the number of NHB trips for those in its zone is the number of NHB trips attracted to each zone. So the next is trip distribution. Trip distribution is a process by which the trip generated in one zone are allocated to other zones in the study area. So these trips may be within the study area or between the study area and areas outside the study area, or we call internal or internal na external. For example, if the trip generation analysis results in estimates of 200 HBW trips in zone 10, then the trip distribution analysis would determine how many of these trips would be made between zone 10 and all the other internal zones. The next is gravity model. So the most widely used and documented trip distribution model is the gravity model, which states that the number of trips between two zones is directly proportional to the number trip attractions generated by the zone of destination and inversely proportional to a function of time of travel between the two zones. Mathematically, the gravity model is expressed as they have a formula. So T, capital T, and the small I and small g equals to pi bracket or close parenthesis a j big small letter f big letter or f I j. So as we can see this page number 21, so where if you ask what is the ig, it is all about number of trips that are produced in zone I in zone and I and attract to zone Z, and the P and the small letter I is a total number of trips produced in zone I, and A big letter A and small letter J number of trips attracted to zone Z, and the FIG a value which is an inverse function of travel time, and the KIG is a socio-economic adjustment factor for interchange IG. So as we can see, this is full factors, F factors. So we can see smooth values and unsmooth values. And the second topic is growth factor values. So trip distribution can also be computed when the only data available are the origins and relations and destinations between each zone for the current or base year, and or trip generation values for each zone for the future year. This method is widely used when O minus D data were available, but the gravity model and the calibrations for if factors had not yet become operational. So this is her formula where, so as we can see, they have a TIG also as like gravity model, but not the same in used in later. So they have a TIG number of trips estimated from zone I to zone Z. So TI percent trip generation in zone I, JX so growth factor of zone X, TI so TI small or is equals TI is equals or TI small or G big Z or ZI big ZI rather, so equals is future trip generation in zone 1, TIX number of trips between zone I and other zone X, TIG percent trips between zone I and zone Z, TG growth factors zone I. The following example illustrations that use words factor method. So mode choices that aspect of the demand analysis process that determines the number or trips between zones that are made by automobile and the transit. The selection of one mode or other is an example process that demands on factors such as travel's income, the ability of transit service or auto ownership, and the relative advantages of its mode in terms of travel time, cost, comfort, convenience, and safety. There are the three types of mode choice models. So first is the direct generation of transit trips. use trip end models and trip interchange models split models. And the second is they have a direct generation models. So a direct is a transit trips can be generated directly by estimating either total person trips or auto driver trips. So in figure 12.8 on page 614 is a graph that illustrations that relationship between transit trips per 100 per trips per day per 1,000 population and persons per versus auto ownership. So as density of population increases, it can be expected that transit riding will also increase for a given level of auto ownership. So as you see in this figure, so the density and auto ownership per household. So and the next is trip end models. The trip end models is to determine the percentage of the total person of the auto trip that will use transmit transit, or estimates are made prior to the trip distribution phase based on a land use of socio-economic characteristics of the zone. So the following procedures are: the first is generate total person trip productions and attractions by trip purpose. The second is compute the urban travel factors, and the third is determine the percentage of these trips by transmit using a mood choice curve, and the fourth is apply auto occupancy factors and distribute transit and auto trips separately. So there are trip interchange model. So when say trip interchange model is in this method, system level of service variables are considered, including relative travel time, relative travel cost, economic status of the trip maker, and relative travel services. Example of this procedure is illustrated using the QRS method, which takes account of the services parameters in estimating mode choice. The QRS method is based on the following relationship, where here's the formula. So where is MS is proportion of trips between zone I and G using transit, and the MSA is proportion of trips between zone I and using auto, and the next is a value referred to as the impedance of travel of mode between I and J, which the measures of the total cost of the trip. So as you can see, this is a impedance in vehicle time per minutes plus the quantity 2.5 times exercise time minutes quantity plus quantity na sa 3 times trip cost divided by income earned minutes. So B is exponent, which depends on trip purpose, and M for transit mode for auto mode. Logit models is a alternative approach used in transportation demand analysis is to consider the relative utility of its mode as a summation of its modal attribute. Then the choice of the mode is expressed as a probability distribution. For example, assume that the utility of its mode is her her formula, and it the formula means here is where ux is a utility for mod x, and n is a number of attributes, and xt is a attribute value or time cost and so forth, and a1 is coefficient value of attributes. Negative since the values are disutilities. If two modes auto and transit t and auto is a are being considered, the probability of selecting the auto mode a can be written as p times a equals to e power of ua divided by e power of ua plus e power of ur. This is her formula, and thank you.